See, divisibility rules, very important now. As I told you in the very beginning of the session, right, while taking up the session, and I promised you that without using formulas, I will tell you how to solve the questions, right? So if you want to learn the techniques, how to solve without using the formulas, then you should be aware of how the divisibility rules as well. Have to be implement the divisibility rules. Here you are having while you're using the shortcut things, you are having 2 to 3 different concepts: the range, divisibility rules, approximation techniques. So where and when necessary, I will discuss all those logics, all those concepts for you, like for option verification thing. And the next thing, divisibility rules is very, very important. And this is very useful for you, especially when you are dealing with option verification thing. And you will be having direct clues in your question, right? Upon seeing those clues and directly verifying the options by using the divisibility rules, right? You can calculate the answer directly, and without going through the entire procedure, you will get the answer directly. You can solve it. Yes, do we need a break for 5 minutes? 5 minute break is okay? Yes? Okay. So after divisibility rules, I guess we will be solving the questions. So it's what's the time now? 3:50 right now. We'll be back at sharp 3:55. Just 5 minute break and we will start solving the question. Okay. Just refresh your mind and come back to session so you can leave it as it is. Mute yourself, take a break, and be back after 5 minutes. Yes, everyone. Are you back again? Yes. Let's go. Yes. Ready? Everybody. I need that energy levels here. Yes, yes, very good, very good. So as I told you, we can't find a question like that directly. They won't ask you whether this is divisible by 2 or divisible by 3, right? So they will give you applications, or else the most important application of the divisibility rule is when you're going with option verification. So just recollect all the divisibility rules, right? Let's recollect all the divisibility rules for the numbers, right? Smaller numbers. That's more than enough for us. So what is the divisibility rule of 2? We are all aware of it, right? Last digit should be even number. In short, I can also write it like last digit should be either 0 or a number divisible by 2. Just I'm modifying it because we know that if the last digit is even number, that means 2, 4, 6, 8, 0. So I just split it into 2 different categories, either 0 or a number divisible by 2. Right? I can do it in that way. Similarly, for 4, last 2 digits should be either zeros or a number divisible by 4. And 8, see, 2, 4 and 8 will come under one category. For 8, last 3 digits should be either zeros or a number divisible by 8. Got it? 2, 4 and 8, same categories, similar divisibility rule, same divisibility rule. But for 2, you will be verifying only last digit, but for 4, last 2 digits, and for 8, last 3 digits. Last digit should be either 0 or a number divisible by 2. 4, last 2 digits or a number divisible by 4. 8, last 3 digits should be either zeros or a number divisible by 8. And we know divisibility rule for 5 and 10. Very simple. 5, that should end with either 5 or 0. 0, last digit should be 0. Next. 3 and 9. 3 and 9 will come under one category. So let's recollect that as well. 3, 9. What is the divisibility rule of 3? Sum of the digits is divisible by 3. Then entire number is divisible by 3. And sum of the digits, very good, divisible by 9. Entire number is divisible by 9. Very good, ma, Naimisha. But like like I don't think that every student will think it in that way. But whenever I come across like few students, what did they do is, right, instead of finding the divisibility rule for 3, they will find it for 9 because thinking that both of them are one and same. But my dear friend, Please make a note of this one. See what is the, if you look at the 3 table, you are having 3, 6, 9, right? And 3 4s are 12, 15, and so on. And in 9 table, if you read the 9 table, 9, 18, 27, and so on. See, all the numbers that will go in 9 table will get cancelled in 3 table. Why? Because 9 means you are having a 3 in it. 1 3 is present, right? So it will cancel in 3 table. But all the numbers that will go in 3 table will not go in 9 table. So if you look at this one, these numbers will get cancelled in 3 table, but they won't go in 9 table, right? So if you are verifying it for 3 table, please verify it for 3 table. If you are verifying it for 9 table, please verify it for 9 table, because this is the reason. All the numbers which will go in 3 table will not go in 9 table, and vice versa. All the numbers will, but vice versa is true, because 9 table, whatever, like in 9 table you're having 9, 18, 27, and so on. So all these numbers will get cancelled in 3 table, but all the numbers that will get cancelled in 3 table will not go in 9 table. Vice versa is not possible. So you are looking for 3 table, divisibility rule of 3, verify it for 3. If you're looking for divisibility rule of 9, verify it for 9. Clear? So that's the reason behind this one. And next question, we are done with 2, 3, 4, 5, 6, 7, 8. We have to discuss those numbers, 6 and all. So let's discuss 6 later. Let's discuss 11 now. Now, what is the divisibility rule of 11? The sum of the digits at even positions and sum of the digits at odd positions, if the difference between both of them is either 0 or 11, then it is divisible by 11. That means, let me give you an example. Let's take randomly some number 5, 4, 3, 2, 0. Let's say, okay, the difference between the sum of the digits at odd positions and sum of the digits at even positions should be either 0 or 11. Odd positions, add the numbers 8. Even position, second place, fourth place, add these numbers 6. Difference between these two, 8 minus 6 is 2. So this is not divisible by 11. As per the divisibility rule, you should get either 0 or 11. For example, let's say 1 3 3 1. So sum is 4, sum is 4. Difference between these two is 0. So this is exactly divisible by 11. Got it, everybody? Clear to you all? Divisibility rule of 11. Yes, okay. Now let's discuss. See, till now we have discussed prime numbers, right? Now let's discuss the composite numbers. Very important now. Divisibility rule of composite numbers. Any composite number. So let's say 6, 12. Vivek, yes, definitely after completing this, I will once again repeat divisibility rule for 11. Okay? Yeah. So for 6 and for 12 or any other composite number, the divisibility rule is you have to choose a co-prime factor pair. Now, what do you mean by co-prime factor pair? It's a factor pair which are co-primes. So, for example, let's say 6. How can you write 6? 1 6 are, 2 3s are. No other scope, right? So definitely you can't choose it. So we will choose this one. 2 and 3 are co-prime numbers. So how can you write the divisibility rule of 6? If a number is divisible by 2 and 3, then it is exactly divisible by 6. See, multiplication indicates and. Okay, that means it should follow the divisibility rule for both 2 and 3. So it should satisfy the conditions for divisibility rule of 3 and as well as 2. If any one condition fails, let's say it satisfied the condition for 3, but the condition for 2 is getting not satisfied, it's getting unsatisfied, right? Now in that case you will say that it is not divisible by 3, so divisible by 6. So both the conditions should be satisfied. If any one condition fails, right, you will say that it is not divisible by 6. Similarly, let's say 12. I can write this one as 1 into 12 and then 2 into 6, 3 into 4. Say I can't choose 1 and 2 because direct verification and taking this one as a formula, both of them are one and same. So you're having factor pairs are 2, 6 and 3, 4. See, if you take 2 and 6, these are not co-primes. Why? Because both of them will get commonly cancelled in 2 table. So I can't choose this pair. So 3 and 4 are composite pairs, so co-prime pairs. So this will be the divisibility rule. If a number is divisible by 3 and 4, then it is exactly divisible by 12. If any one condition fails, then we will say that it is not divisible by 12. Why did I tell you this thing? Why? Because previously in TCS paper, or I guess, or CAPG or CTS, I don't remember, they have given you the options. At A, B, C, D. Options are given to you, and the question is, which among the following is exactly divisible by 90? This is the previous year question, placement paper question. Which among the following, direct divisibility rule application. So there, see, all the options are like 5-digit numbers. So if you keep on dividing each and every number and verifying whether it is getting exactly divisible by 90 or not, time taking thing, right? So instead, what are the co-prime factors now for this? Anybody in the class? Factorize those numbers. Very good. Very good, Manish. Very good, ma. Sriram. Danita. Very good. You got it right. 9 and 10. So now I verify it for 10 table and I will verify it for 9 table. So for 10, last digit should be 0. So verify which among this following options is not satisfying the condition for this one. So that will be ruled out. That's it. And in the remaining options, just verify which among those following is exactly divisible by 9. You'll get the answer. Just application of this one. Few of you might get a doubt that, ma'am, why didn't we choose 2 and 45? Because 2 and 45 are also prime numbers. Yes, definitely they are also co-prime numbers. But for 5 again, you should verify it. For 45 again, you should verify for 5 and 9, right? So 3 different numbers. Instead, better to go with this one, 9 and 10. Got it? Similarly, they asked it for 80 as well, I guess. 80, I do think so. I don't remember it. So this is the application, right? Whenever composite numbers are given, you have to choose a prime factor pair. And one of you asked me for divisibility rule with 11. Let us take one more example. Let's say 7, 2, 4, 8, 6. This is a number. See, first number, third number, fifth number, odd positions. Random numbers now, alternate numbers, 2 and 8. Add these two, 10. What about this one? 4 plus 6, 10, 10 plus 7. Add all these numbers, 17. Subtract these two, 17 minus 10, which is equal to 7. So this value, you should get this value as either 11 or 0. If you get 11 or 0, it is exactly divisible by 11. If you get any other number other than 0 and 11, you will say that it is not exactly divisible by 11. So this is not divisible by 11. Here, add alternate numbers, subtract the resultant values. You should get either 11 or 0. Clear? Yeah, got it? So keep these divisibility rules in mind. I will tell you where and when necessary how to use it. Now, can you please for 7 and 11? Sure, Manish, I will tell you. Meanwhile, others, which one, Naimisha? Meanwhile, others, just make a note of this one. Take a screenshot or copy this question. Keep solving this one and give me your answers, okay? Yes, Manisha. Sorry, Naimisha. Can you explain what? 7 and 11. Okay. See, 11. See, 11 is simple, ma. Adding alternate numbers. First number, third number, sixth number. Add the numbers. First number, third number, fifth number. Nothing but odd position number. Add them. 6 plus 4, 10, 10 plus 7, 17. And even position number, that means second place, fourth place. If you are having sixth place as well, add that number. You're having only two places, second and fourth, add those two. 2 plus 8, 10. Now this resultant and this resultant, subtract these two. I'm getting 7 here, right? If I am getting 7, that means it is not divisible by 11. I should get either 0 or 11. If I get either 0 or 11, then I will say it is exactly divisible by 11. Else it is not divisible by 11. Clear, Naimisha? Yes? Okay. And for 7 and 13, see, for 7 we are having a technique, but rather than using that technique, I would directly suggest you to multiply it with 7. Why? Because that will give you a faster response, faster answer compared to that of the divisibility rule here for 7. The thing is, let's say you're having a 2, 3, 4, let's say this is a number. So multiplying this with 2, you're getting 8, subtract it from the remaining numbers, remaining digits. Okay, so whatever answer you're getting here, right? If this is divisible by 7, then an entire number is divisible by 7. If not, it is not divisible by 7. Since it is a 3-digit number, it is sufficient for me to multiply with 2 one time, right? But you're having more number of digits. You have to keep on repeating this process until you reach a number that is getting divisible by 7 or not, until you reach that number, so that you can judge whether it is divisible by 7 or not. You have to keep on repeating the process. What happens there is, as long as the numbers get increased, like for a 5-digit or a 6-digit number, you have to repeat the cycle again and again. So better to go for direct division with 7 rather than going with the cycle. Clear, ma? Everybody? So that's the reason for those two prime numbers 13 and 7, I would suggest you to go for direct division. Clear? Okay. So don't worry, hardly we will see till 12, or else in some cases, as you have seen like before in the thesis or placement paper questions, they ask it for 90, right? So application of that one. Apart from that, we don't get anything else from the divisibility rule. But application wise, right, option verification wise, we need divisibility rule. Very good, Manish. So Manish says he got 6. Option D is the answer. Anyone else? Any other answers? The same answer or any other answer for this one? Okay, 2, option B. Danita, option C. Okay. Okay, option B. Neha, 2. Danita, C, 4. Okay. Anyone else? Any other answers? See, all these are separated by multiplication. Each and every exponent is separated by multiplication. So you have to multiply the values and tell me the answer, right? So 1 to the power of anything, Naimisha, okay, C. Meanwhile, you just keep on posting your answers. Others, you can cross check here or else you can solve it along with me. So 1 to the power of anything will be 1. Okay, done. So 3 to the power of 72. What is the span of 3? 4. So 72 when divided by 4, what is the remainder? Remainder is 0. It will get exactly cancelled, right? So remainder is 0. So raise it to the maximum power value. So 3 to the power of 4 into. Next, 61. Base is 8. So span of this one is 4. So 61 when divided by 4, the remainder is 1. So 8 should be raised to the power of 1. Very good. 8 power 1 into 51, and span of 7 is 4 again. So 51 when divided by 4. See, 48 will get cancelled. So 3 is the remainder. So 7 should be raised to the power of 3. Okay. Very good. Very good. So I'm getting answers like span of 8 is Neha. We are having span values as either 1, 4 or 2. That's it. See, check for 8. You will get 4, not 5. Okay. So now let's look at it, this one. For no, Harita. Span value of 7 is 4, ma. 7 ones are 7, 7 square 49, 7 cube 343, 7 power 4 2401. 4 values. 4, ma. So I told you, right? Remember it in this way: 2, 8, 3, 7. So if you add these two numbers, you will get 10. You add these two numbers, you will get 10. So that's the reason I wrote it in this way. Span values for all these set is 4. And 1, 5, 6 it is 1. For the rest of the numbers, it is 2. What are the remaining numbers we have? 4 and 6. Sorry, 4 and 9. It is 2. Okay, don't get confused. We are having either 1 or 4 or 2. That's it. So 1 into 3 power 4, 81, 1. This is 8. 7 cube, 343, 3. So multiplication, you will get 24. So you will keep 4 here and 2 will go for right. Carry forward it, right? So 4 will stay here. So last digit is 4. So option C.